Here the question is given here from the parabola. One of the most important LQ. One of the most important LQ here. So if y1, y2, y3 are y coordinates of the vertices of a triangle inscribed in the parabola, y square is equals to 4ax. Then show that the area of the triangle is 1 by 8a into modulus y1 minus y2 into y2 minus y3 into y3 minus y1 square units. Okay. So what is given here? So what is given here? What is given in the question? Given that y1 comma y2 comma y3 are y coordinates of vertices of triangle. What? Okay, so y coordinates of vertices of the triangle. Triangle inscribed in the parabola y square is equals to 4ax. And what is given parabola? Y square is equals to 4ax is a given parabola equation. Okay. So and what are the points? Let I am taking a of x1 comma y1. Okay, y coordinates are given. We don't have the x coordinates. So since y coordinates are y1, y2, y3, so x coordinates we consider as x1, x2, x3. So A is a point x1, y1, and B is another point, that is x2 comma y2, and C is one more point, that is x3 comma y3. x3 comma y3 are the vertices, required vertices here. Vertices of triangle ABC. Triangle ABC. Okay, so consider the triangle as ABC triangle. So now what is the parametric form? Parametric form. Here, point for the parametric form. Parametric form is equals to P of x comma y is equals to a t square comma 2at. This is the parametric formula. Okay, so in the parabola. Okay, so what is the formula, ma? A t square comma 2at. Repeat the formula. A t square comma 2at. Repeat the formula. What is the formula parametric form? A t square comma
280.
Once again, a t
square comma 280.
Very good. Okay, so the formula, repeating the formula is important. If you are perfect with the one or two formula, you can solve the problem easily. Okay, remaining simplification part is easy. You have to remember the formula. Okay, so a t square comma 280 is the formula. What is the formula? A t square comma 280 is the formula. Now, after that, we have to write all these points in the parametric form. So now, if we write here, so a of x1 comma y1, a of x1 comma y1 is equals to a of a t square comma 280. Okay, but we have 3 points, x1, y1, x2, y2, x3, y3. Like that, we have 3 points. Okay, so how to write them? Okay, how do we write a t1 square comma 2a t1? Like this we can write. Okay, if you take the point B is x2 comma y2, this is equals to a t2 square comma 2a t2. Okay, if you take the next one, that is C x3 comma y3 is equals to a t3 square comma 2a t3. This is the third point. After getting the third point, now we have to find the area of the triangle. For finding the area of the triangle, we have 2-3 formula are there. So which is better? So just you have to select the better one. So I am going to suggest the easy formula. Okay, so for finding the area of the triangle, area of the triangle ABC is equals to delta is equal to 1 by 2 into, okay, so 1 by 2 into the determinant of x1 minus x2. From x1 I am subtracting x2, from x1 I am subtracting x3. Okay, from y1 I am subtracting y2, from y1 I am subtracting y3. Okay, so this is the easiest formula, so that easily you can solve the problem here. Okay, so with this formula, the simplification part will be very easy for you. The solution, okay, is very easy for you. Now, delta is equals to 1 by 2 into x1. What is x1? Okay, here x1 means 81 square. Okay, x2 means 82 square. Okay, next 83 square. From 81 square subtract 82 square. From 81 square subtract 83 square. Understood? Okay, so now if we apply that, from a t1 square subtract a t2 square, from a t1 square you subtract a t3 square. Okay, after that, next y coordinate, we have to take the y coordinate. The y coordinates also like that, from y1 minus y2, y1 minus y3. That means 2a t1 minus 2a t2 and 2a t1 minus 2a t3. It is very simple. Just to try to understand how we are solving the, okay, problem, how we are, okay, applying, okay, 2a t1 minus 2a t2 and 2a t1 minus 2a t3. Okay, so now remaining, okay, so in this 1 by 2 as it is I am writing. So we can take anything common from any row or any column. Okay, so from first row we have a. Okay, so we can take a common from the first row. A common from the first row. That means t1 square minus t2 square. Next one here, t1 square minus t3 square. Okay, other than a. I took a common from the first row. And second row, if you take the second row, observe carefully, we have 2a, 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 2a. Okay, so you can take 2a common. Okay, so in separately for this element, then complete from the row, we can take 2a common. So I am taking 2a common. Okay, so 2a common means other than 2a, what is remaining here? So remaining here t1 minus t2. Other than 2a, here t1 minus t3. t1 minus t3. Okay, do you know the formula a square minus b square formula? Here you can cancel this 2 and 2. In the outside, you can cancel the 2 and 2. Okay, so here a into a is a square. A into a is a square into t1 square minus t2 square. We can write it as a square minus b square formula. Tell me a square minus b square formula. That is a plus b into a minus b. A plus b into a minus b. So that means t1 plus t2 into t1 minus t2. t1 minus t2. Okay. So and tell me the formula for this also. t2 t1 square minus t3 square we have. Okay. So what is the formula? What is the formula here? Okay, what we can apply, what we can write? t1 minus t3 into t1 plus t3 and t1 minus t3, right? So t1 minus t2 here and t1 minus t3 here. Okay, so what formula we are using here? What formula, ma? What is the formula? Tell me first. What formula we use?
Delta is equal to 1 by 2 mod of
No. Here. Okay, from this step. Okay, we use what formula we use for splitting this? A square minus b square is equals to a plus b into a minus b. Tell me the formula once again. A square minus b square is equals to a plus b into a minus b. What is the formula? Repeat once again. First. A square minus B square is equals to A plus B into A minus B. Okay. All of you repeat this formula. Area of the triangle ABC, delta is equals to 1 by 2 into, okay, so determinant of x1 minus x2, x1 minus x3, y1 minus y2, y1 minus y3. Okay, repeat the formula once again. Delta is equals to 1 by 2 into determinant of x1 minus x2, x1 minus x3, y1 minus y2, y1 minus y3. Repeat fast. Yes. Repeat the formula. Delta is equals to 1 by 2 into x1 minus x2, x1 minus x3, y1 minus y2, y1 minus y3. Fast.
The delta is equal to 1 by 2 mod of x1 minus x2 into x1 minus x3, x1 minus
y1 minus
x3.
y2, y1 minus y3.
Yeah,
Very good.
y1
Okay,
minus
once
y2,
again,
y1
once
minus
again, once again.
Delta equals to 1 by 2 mod x1 minus x2, x1 minus x3, y1 minus y2, y1 minus y3.
Yes, this is the determinant. That's why we are applying the determinant properties. Okay, determinant properties. Okay, so now if is here anything is common in the row wise or column wise, check it once again, ma. So here in this here t1 minus t2, t1 minus t2, t1 minus 3, t3, t1 minus t3. Okay, we can take it common, right? Okay, so now I am taking common. If we take it common, okay, so then if we take it common, okay, so then we get it as a square is outside. Okay, we have delta is equals to outside a square as it is, and what is common in the first column? First column t1 minus t2 is common. Okay, t1 minus t2 is common from the first column. What is remaining? What is remaining? Okay, if we take it common, what is remaining here? What is remaining? Okay, if we take it common, so the remaining are t1 plus t2, t1 plus t2, okay, and one is okay, so remaining here t1 plus t2, I am writing here t1 plus t2 and 1. Okay, and so I'm taking t1 minus t3 common from the second column. What is common in the second column? T1 minus T3. Okay, so take T1 minus T3. Okay, so common from this T1 minus T3 is common from the second column. What is remaining here? Okay, T1 plus T3 and 1. T1 plus T3 and 1. T1 plus T3 and 1. Okay, so now this is equals to a square into t1 minus t2 and t1 minus t3, t1 minus t3. Okay, how to find the determinant of 2 by 2? Product of these two minus product of these two. Okay, so if we apply, then what we get here into t1 plus t2 into 1 is t1 plus t2 minus of t1 plus t3 into 1 is t1 plus t3. Okay, so now this is equals to a square into t1 minus t2 and t1 minus t3, and okay, so here t1 plus t2 minus t1 minus t3 minus t1 minus t3. Okay, so in these two term, okay, so t1 we can cancel the t1 and t1. What is remaining here? This is equals to a square into t1 minus t2 and t1 minus t3, okay, and t2 minus t3. Okay, so in this okay, so starting itself t1, t2, t3. Okay, so do we have any values for t1, t2, t3? and final answer. We want the final answer in terms of y1, y2, y3. Okay, almost we are getting the answer. Okay, but final answer we want in terms of y. Okay, so that means, is there any relation between the y1 terms, y1, y2, y3? Okay, we have the y1 value as 281, y2 value as 282, y3 value as 2a t3, 2a t3. Okay, so from this, what is t1 value? T1 value is equals to y1 by 2a, y1 by 2a. Like that we can write. Like that we can write. Okay, so that means we know that y1 is equals to 2a t1. This implies t1 is equals to y1 by 2a. T1 is equal to y1 by 2a, and y2 is equals to 2a t2. This implies t2 is equals to y2 by 2a. Okay, and in the similar way, okay, so y3 is equals to 2a t3. This implies, what is t3? T3 is equals to y3 divided by 2a, y3 divided by 2a. Okay, if we apply all these three values, okay, then we get it as a square into t1 minus t2. What is t1 value? y1 by 2a, y1 by 2a minus t2, y2 by 2a, y2 by 2a. Okay, into t1 minus t3, t1 minus t3. Okay, t1 value is y1 by 2a minus t3. Okay, that is y3 divided by 2a. Okay, so next t2. What is t2 here? y2 by 2a, y2 by 2a minus t3. Okay, that is y3 by 2a, y3 by 2a. Okay, take LCM here. Take LCM, a square into, okay, outside a square as it is. Okay, in the remaining terms, 2a is the LCM. So add the numerator. Both the denominators have 2a, so y1 minus y2 we get. Okay, we get y1 minus y2. Okay, and after that, here also 2a, we get it as y1 minus y3. y1 minus y3. In the next factor also, 2a is LCM, y2 minus y3 we get. Okay, 2a and y2 minus y3, y2 minus y3. So 2a. So you can write this 2a outside completely. Okay, we get 2a into 2a into 2a. Okay, so a square divided by 2a into 2a into 2a. Okay, so and into, so y1 minus y2 and y1 minus y3 and y2 minus y3. Okay, here can you cancel anything in this? Okay, here a into a is a square. You can cancel the a square. You can cancel the a square. So now this is equals to 1 divided by 2 times is 4, 2 times is 8, and 2a, 8a, 8a, and y1 minus y2, y1 minus y2. Okay, y2 minus y3 I am writing in the second place. Okay, and the next position I am going to write y3 minus y1, y3 minus y1. Okay, instead of y1 minus,
everything no open cheyanappo idne display ang vellotu annu you either either
okay, so here y1 minus y2 and y2 minus y3 and y3 minus y1, y3 minus y1. Here actually we have y2, y1 minus y3. How can we write y3 minus y1? How can we write y3 minus y1? Area is always positive. Okay, so in this, okay, we are taking common. Just think that we are taking common. So that, okay, so we are interchanging here. We are interchanging here. That's why we are taking minus extra. Just think that. So area is always positive. Area is always positive. area is always positive. Therefore, okay, required area is equals to delta is equals to 1 by 8a into mod of. That's why always we keep the okay modulus symbol. Okay, so we want the answer in order y1 minus y2, y2 minus y3, and y3 minus y1. This is only the required solution. Square units. Okay, once check the answer what we want. Okay, so just check it once. Okay, so here okay, area of the triangle we have to prove 1 by 80 into y1 minus y2 into y2 minus y3 into y3 minus y1 square units. This is